We tagged 4 or 5 great white sharks, and one of them in particular, Shark Alpha, was around 9-10 feet in length. The ocean has no shortage of killers, but sometimes the real monster isn't the one you expect. Scientists tagged a powerful great white shark, thinking they were following an apex predator. Instead, they were tracking a target. The shark vanished without a trace, leaving only a battered tracking tag and a trail of chilling data. What could take down this monster without a trace? A giant squid, a killer whale, or something far more terrifying? This is the true story of a predator that became prey and the quest that finally revealed its killer, the disappearance of Shark Alpha. The southern coast of Australia was quiet that morning in 2003 as a small research boat pushed off from Bremer Bay and into the cold, endless stretch of the Southern Ocean. On board were scientists from CSIRO, one of the first teams in Australia to use pop-up satellite tags to track great white sharks. These weren't just ordinary trackers. They were compact black boxes built to log temperature, depth, and light every few seconds. Once detached, they floated to the surface and beamed the data to satellites overhead. For the early 2000s, this was cutting edge. The mission was simple. Follow one great white through an entire season and uncover the hidden paths of one of the ocean's most elusive predators. Before long, a large female shark emerged from the deep. She was about 9 feet long, roughly 3 m, and carried the kind of battle scars only a survivor earns. The team called her Shark Alpha. She didn't thrash or panic. Instead, she moved with eerie calm, circling the boat once, then sliding close enough for the researchers to attach the tag just below her dorsal fin. The anchor barb locked in place beneath her skin. And within seconds, she kicked away with a powerful flick of her tail and vanished into water so cold it numbed bare skin in seconds, around 8 degrees Celsius. Nobody on board had any idea they just tagged the shark that would spark one of the most baffling mysteries in marine science. For 4 straight months, Alpha's tracker worked like clockwork. The data showed her rising slowly toward the surface during the day to warm up in sunlight, then diving into deep canyons that dropped hundreds of feet below. Water temperatures hovered around 5 degrees in those depths, but Alpha's core stayed warm. Great whites are regional endotherms, meaning they can keep their body temperature up to 20 degrees Celsius above the surrounding water. Most keep their muscles between 25 and 26 degrees Celsius. That's about 78 degrees Fahrenheit, no matter how cold the ocean gets. Alpha followed food trails, lingered near seal colonies, and circled around drifting whale carcasses. Her movement patterns matched what CSIRO would later observe in more than 200 great whites tagged off Australia's southern coast. Every new data point fed directly into migration models that researchers hoped would one day support white shark conservation efforts worldwide. Then on the night of Christmas Eve, everything changed. At around 23 minutes past 11, Alpha's tracking data showed a sudden drop. Not a slow foraging descent, but a free fall. In just 20 seconds, she plunged from the surface to nearly 600 meters below, over 1,900 feet. It was the steepest, fastest recorded dive by a white shark in Australian waters. Usually, when a shark is in distress or attacked, its movement data becomes erratic, a zigzag of escape attempts. But Alpha's path was a straight arrow, clean and controlled. Then the temperature reading jumped from the cold 8 degrees of the open ocean to 25 degrees Celsius or 78 F. That could only mean one thing. The tracker was no longer in the ocean. It was inside something alive. 4 days later, someone walking along the beach stumbled upon a small plastic device battered and coated in salt and seaweed. It had washed ashore roughly 4 kilometers from where Alpha had last been tracked. When the scientists recovered it and downloaded the data, the mood turned cold. Dave Riggs, the cinematographer who filmed the original tagging operation, later described the moment as a gut punch. The numbers told a story that defied explanation. A 9ft apex predator swallowed whole, and the only witness was a tag built to track depth and light. Now, great whites are capable of diving deep. One shark tagged off the South African coast reached depths of 1,200 m back in 2010. But those kinds of dives usually happen slowly during foraging, not in a 20-second vertical drop. And they definitely don't come with a 30-degree spike in temperature. That sudden rise was more consistent with the internal temperature of a large marine mammal or another lamnid shark. Still, scientists had never recorded a great white attacking another of Alpha's size. Not like this. The tag didn't drift into a carcass. It was swallowed directly into something alive with muscles warm enough to register 78 degrees. The implication was chilling. Alpha had been eaten alive, and the predator responsible did it so cleanly that no surface disturbance was ever reported. By early 2004, the researchers submitted their findings to Australia's Department of Environment. In the report, they flagged it as an unusual mortality event, a term usually reserved for whale strandings or mass die-offs. A few months later, the story started leaking into media reports, and fascination exploded. That single tag gave rise to one of the most haunting cold cases in marine science. One that would eventually lead to the Smithsonian documentary hunt for the super predator. But back then, the questions were simple and terrifying. What lives deep enough and strong enough to pull down a shark like Alpha? If it could happen once, had it already happened dozens of times without anyone knowing? More than 2 decades have passed since that dive, and today's tracking tags are miles ahead of what Alpha carried. They log more data, send it faster, and offer 4 times the resolution. And now there are satellite receivers all along the southern shelf from Western Australia to Tasmania. Still, the Southern Ocean keeps its secrets. Tags go silent. Temperatures spike without warning. Sharks vanish mid-transmission. Some dives recorded today still don't make sense based on known physiology. And every time something unusual shows up in the data, scientists go back to Alpha's tag. That single moment, her final descent, remains the benchmark for every anomaly they find. That plastic device, half buried in sand, marked the last traceable moment of Shark Alpha's life. But it also marked the start of a new kind of mystery. Because all the team could say for certain was this. Somewhere in the black freezing depths of the Southern Ocean, there's a force capable of swallowing a great white shark whole without leaving a ripple behind. But the force behind it was something no one was prepared to face. Theories behind Alpha's disappearance. When Shark Alpha's tag revealed its final chilling data, the reaction wasn't just scientific. It was explosive. In days, word spread from research boats to media networks, online forums, and conference halls. Experts and amateurs alike raced to explain what could have taken down a 9ft great white and swallowed it whole, leaving behind only a data tag and a trail of questions. Some lean toward the colossal squid theory. These deep-sea giants, rarely seen alive, are pulled from the Ross Sea with eyes the size of dinner plates and suction cups lined with sharp hooks. They've been known to battle sperm whales in the dark ocean layers hundreds of meters down. If anything could ambush a shark in complete silence, it might be this. In fact, Alpha's tag recorded its final dive to nearly 2,000 feet, the very zone where giant squid are known to hunt. And in 2020, scientists recovered a white-tipped shark covered in massive sucker marks, wounds only a large squid could have inflicted. But there was a problem. Colossal squids are cold-blooded. They live in waters just above freezing. Alpha's tag had recorded a sudden temperature spike to 78 degrees Fahrenheit. That meant it ended up inside something warm-blooded. That number made the squid theory hard to defend. Others pointed to killer whales. Orcas are widely known as the most intelligent predators in the ocean. And off South Africa, one particular male nicknamed Starbird made headlines in 2023. He was filmed attacking a great white and devouring only its liver, a highly nutritious organ, before leaving the rest. The attack lasted under 2 minutes, and after it, an entire bay of great whites cleared out for weeks. Now, if a single orca could do that, what could a full pod do in a place like Western Australia? Then came the theories that strayed into prehistoric territory. The megalodon, an ancient predator that grew over 60 feet long, entered the conversation. Its fossilized teeth, sometimes larger than a human hand, have been found all over the world. No confirmed sightings exist today, and modern science says they've been extinct for over 3 million years. But the mystery of Alpha's disappearance had people asking, if Megalodon didn't do it, then what did? Beyond these, some stranger theories began gaining real attention in the months after Alpha vanished. And while some sounded like science fiction, they were backed by facts that made even seasoned researchers pause. One of the more grounded ideas focused on the blunt-nosed six-gill shark, a primitive deep-sea predator, sometimes called a cow shark. These aren't small fry. Fully grown six gills can reach over 20 feet long and roam thousands of feet below the surface. They rarely come into view, but remote-operated submersibles have captured footage of them stalking wrecks nearly 900 foot down in places like Ormoc Bay. In 2023, one of these giants actually washed up near Benidorm, Spain, measuring almost 15 feet. It was a stark reminder that enormous little-known predators still swim the depths of modern oceans. In theory, a six-gill could have taken down Alpha slowly, dragging her into the dark and digesting her without much thrashing or noise. Their cold-blooded biology suits the icy waters of Bremer Canyon. But that cold blood is the same thing that likely rules them out. That led some to look further back in time, way back. Fossils of Mosasaurus, a gigantic marine reptile from the late Cretaceous, show jaws designed to crush bone and a bite force that might have outclassed even T-Rex. These monsters could grow beyond 56 feet long and once dominated the oceans. A few fringe theorists argued that if anything from the age of dinosaurs could have survived in deep ocean trenches, it might be this. But the facts don't cooperate. Every Mosasaurus fossil ever found dates back at least 66 million years. No DNA, no sightings, no sonar hits, just teeth and rocks and a whole lot of imagination. Then there was Liveton Melville. If any extinct creature could have matched Megalodon in raw power, it was this one. Discovered in Peru in 2010, Liveton was a type of raptorial sperm whale with foot-long teeth, the largest biting teeth of any known animal. Some paleoceanographers even suggested that cooling during the early Pliocene might have allowed a dwarf version of this whale to survive in remote southern waters. It's not totally crazy. Liveton had layers of thick blubber that could have helped it handle freezing depths. But here's the catch. All the fossils date back at least 9 million years. And since Liveton was warm-blooded, its stomach temperature would have been much higher than the 78 degrees recorded by Alpha's tag. These theories, as wild as they sound, weren't tossed aside because they were too weird. They were studied, debated, and dissected by serious scientists. But in the end, none of them lined up perfectly. Dave Riggs, the filmmaker who'd been there when Alpha was tagged, couldn't let it go. Night after night, he paced the deck of his vessel, staring at the exact spot where Alpha's tag had stopped transmitting. That location was in Bremer Canyon, a massive underwater gorge carved into the edge of the continental shelf. The deeper you go, the colder and darker it gets. But each summer, a strange thing happens. Cold water from the bottom rises and mixes with the warm lee wind current. This natural upwelling brings a flood of nutrients that attracts everything from krill to squid to massive whales. With prey come predators. It didn't take long for locals to start calling the center of that canyon something darker, the kill zone. Determined to go back, Riggs scraped together a small film grant and built a custom submersible in his shed. It was a strange-looking creation. Fiberglass panels, salvaged parts from a lawn mower, and just enough ballast to stay afloat. Locals laughed at first, but when the sub went down and came back up with footage, no one was laughing anymore. On its first dive, the camera showed bronze whaler sharks slicing through the water, flashing silver and bronze as they circled the sub, bumping against it hard enough to shake bolts loose. And deeper down, shapes started appearing. Black and white figures moving like ghosts through the twilight zone. These were orcas. Western Australia's orca population swells in Bremer Canyon during the summer months. Researchers have tracked more than 170 individual orcas there in the past decade. They're drawn by the krill blooms and the chain of life that follows. They've been filmed using sophisticated tactics, flipping sharks upside down to stun them, then biting out their livers with surgical precision. Riggs and his team saw fins slicing past the submersible and knew this theory was gaining ground, but again, the numbers didn't add up. Orcas usually hunt near the surface and rarely dive deeper than a few hundred feet. Their internal body temperature, like ours, sits around 97 degrees. Alpha's tag showed 78. That meant whatever swallowed it had a cooler internal environment, ruling orcas out, at least from that specific dive. The deeper the crew went, the more confusing it all became. One dive nearly ended in disaster when around 40 bronze whalers formed a tight wall around the sub. Another was cut short when a pod of orcas shot past at high speed, leaving behind only turbulence. But even in those chaotic moments, the sub's instruments picked up something even stranger. Sonar blips over 1,000 feet below, combined with sudden temperature shifts. It was as if something warm-blooded was moving up and down through the thermocline, just out of reach. Up above, the signs were just as bizarre. Days before Alpha vanished, old footage showed jumbo squid gathering near the surface and dolphins darting nervously around baitfish. Local shark alert networks began flagging warnings whenever whale carcasses drifted toward the coast. These carcasses can attract massive predators into shallows, like what happened at House Beach near Bremer Bay in May 2025 when beachgoers had to evacuate as sharks tore into a whale body just meters from shore. Each new observation made the story more intense. Squid on the surface meant something was stirring below. Nervous dolphins hinted at trouble. And still, not a single camera had caught the predator responsible. A Discovery Channel expedition even lost one of its cameras when a 15-foot white shark bit through the tether and vanished. All that remained was shredded cable and a blur of movement. The canyon itself seemed to follow its own strange rhythm. Drop a light too quickly and everything vanished, as if the animals knew something had changed. Other times, the water would stack into layers. Krill drifting like rusty snow, bait fish glittering below than sharks, and finally the faint shadows of something deeper. Still, that structure hinted at a far more complex predator hierarchy than anyone had fully understood. People became obsessed. Whale watching tours turned into orca safaris. From December to April, boats launched daily, packed with tourists, divers, and film crews from all over the world, each hoping to catch a glimpse of the creature that could take out a great white without a trace. But the canyon didn't give up its secret. Submersibles recorded sperm whales slapping squid, false killer whales chasing tuna, and even rare beaked whales gliding through deep shadows. But no one captured the thing that had swallowed Shark Alpha. No clear footage, no confirmation. By the end of the third season, scientists began to speak quietly about what the search had become. This wasn't just a missing shark anymore. It was a question about the limits of science. How could a top predator vanish in front of one of the most advanced tracking tools ever deployed? What happens below A000 feet that no tag has yet survived to reveal? Every evening, the boats returned to Bremer's harbor. Drones were packed up, cameras wiped down, and Dave Riggs would still be there standing on deck and staring into the black. What they had was sonar echoes, half-chewed bait cages, a few DNA samples that raised more questions than answers. And for Dave Riggs, that meant only one thing. Another dive, another chance to find the answer. Because until something surfaces with teeth and proof, the mystery of Shark Alpha isn't over. It's only growing. Unmasking Alpha's killer. In the quiet hours after failed dives and fruitless debates, Dave Riggs found himself returning to the data from Alpha's tag. He replayed the tag's data so many times it felt like it had burned into his brain. It made no sense that Alpha had been taken by a squid or an orca. The story in the data pointed to something else. Years passed without answers. Then in 2014, researchers at CSRO dug into tag records from 16 other great white sharks that had been tracked in the same part of the Southern Ocean. What they found was chilling. 4 separate logs ended just like Alpha's. A steep, almost vertical descent, a mid-water temperature spike, then nothing. These weren't random anomalies. They were precise repeating events. That changed everything. The team finally faced the one theory that had loomed over them from the start. Alpha's killer was not a squid, an orca, or a Jurassic throwback. She was eaten by another great white shark, a much bigger one. The more they studied the numbers, the clearer it became. Great whites, part of the lamnid family, are warm-blooded. They keep their internal temperature between 30 to 40 degrees Fahrenheit above the surrounding water. The idea of a shark eating another shark might sound like a horror movie twist, but for great whites, it's not even unusual. Cannibalism starts before birth. Scientists have captured footage of great white embryos attacking and devouring their siblings in the womb, a brutal survival mechanism called embryogy. And when they grow up, that instinct doesn't just vanish. Adult whites have been seen turning on their own kind, especially when food is scarce or the potential reward is worth the risk. In 2019, Nat Geo Wild aired a clip from Australian waters where a 15-foot great white nearly tore another shark in half. Researchers analyzed the wounds and concluded the attacker must have been close to 20 feet long. The same year, off the Neptune Islands, divers recorded a series of bite and release hits between whites that looked less like fights and more like tests. Brief probing attacks as if one shark was deciding whether the other was worth the effort. When scientists tried to estimate the size of the super predator that took down Alpha, the numbers were stunning. Based on the drop rate, depth, and sheer force implied by the data, the attacking shark was likely between 17 and 19 feet long, almost double Alpha's size. For context, the largest verified white shark ever recorded, Deep Blue, stretches about 20 feet and weighs over 2.5 tons. A shark of that size could easily swallow Alpha head first and drag her into the abyss like she was nothing. What would drive a shark to cannibalize another of its kind? One clue lies in the liver. The liver of a great white can make up nearly a quarter of its body weight and is packed with squalene, a nutrient-rich oil that offers a massive energy boost. Off the coast of South Africa, orcas have been filmed targeting great whites, ripping out only the liver and leaving the rest of the carcass untouched. The same energy incentive likely applies here. In nutrient-scarce areas like Bremer Canyon, especially in the offs, a shark might take the gamble if the payoff is big enough. The temperature data from Alpha's tag nailed the theory shut. The stomach of a warm-blooded shark holds steady in the mid-70s Fahrenheit. Not as hot as a mammal's, but far above the frigid seawater or any cold-blooded predator. When this conclusion finally broke into the public sphere, it didn't go quietly. Headlines roared with phrases like super predator and cannibal shark. The story exploded across social media, spawning everything from wild theories to terrifying fan art. But for marine biologists, it wasn't just sensational. It was a reminder that even the top predators in the ocean have their own predators. And those killers sometimes swim under the radar. Riggs called it the ocean's oldest rule. There's always a bigger fish. And in places like Bremer Canyon, that rule still applies. For researchers, the findings shook up more than just their expectations. It challenged conservation models. If great whites are regularly preying on juveniles, then human impact isn't the only factor affecting population counts. As for Riggs, he never stopped diving. He still explores the kill zone, piloting his homemade sub into its cold valleys, but now he goes armed with upgraded tags, ones designed to survive higher stomach acid levels and tougher attacks. Meanwhile, the public responded in their own way. Forums flooded with maps, satellite imagery, and frame-by-frame breakdowns of the original data logs. Memorial tributes to Alpha started appearing on everything from surfboards to murals in Perth, San Diego, and coastal towns far from Australia. People weren't just interested in the mystery. They were obsessed with it. And maybe that's because the final answer was both simple and haunting. There was no ancient Leviathan, no resurrected megalodon, no sea monster out of myth. Alpha was taken by her own kind, only bigger, stronger, and just hungry enough. Just as the truth about Alpha settled in, another shark disappeared. And this one was pregnant. The poor beagle shark murder mystery. The poor beagle shark isn't as famous as the great white, but in the cold North Atlantic, it plays a similar role. Sleek, fast, and able to dive deep, this shark is built for hunting in the dark. In October of 2020, a 7-foot heavily pregnant female was caught on a long line off the coast of Cornwall, England. Scientists from the University of Exeter and the Oceanic Management Group saw a rare chance to track one of the ocean's most elusive mothers. They attached two high-tech devices, a pop-up satellite tag and an acoustic transmitter. These devices would record depth and temperature every few seconds and were programmed to detach and surface after 9 months. If everything went as planned, the shark would lead them straight to her offshore nursery. And for a while, things went exactly that way. For almost 100 days, the data came in clean. The shark swam steady vertical loops, rising to the surface and diving down to about 200 feet, likely chasing herring and mackerel. It was a clear, predictable feeding pattern. But just after midnight on New Year's Day, everything changed. The shark's movement data suddenly spiked. In only 6 minutes, she plunged straight down to 560 m, more than 1,800 feet, far faster than any glide she'd made before. Then the water temperature around the tag jumped from 8 degrees Celsius to 25. That's 75 degrees Fahrenheit. and it didn't budge for 36 hours. After that, the tag data turned chaotic, bouncing erratically until the device eventually popped free. When it surfaced, it was almost 800 kilometers southwest of the dive site and began sending its log to orbiting Argo satellites. At first, researchers thought maybe she'd swallowed the tag by accident while feeding. But poor beagles, unlike their great white cousins, their internal temperatures matched the cold ocean around them. A steady 75 degrees reading meant the tag had entered something warm-blooded, but not too warm, so seals, pilot whales, and other mammals were ruled out. Like shark alpha, the most likely explanation was a much larger lamnid shark. Great whites keep their stomach temperatures in the exact same range between 24 and 27 degrees Celsius. That's right in line with the 36-hour heat plateau the tag recorded. BiteForce models run by the same research team showed that a white shark at least 14 feet long would be strong enough to crush a poor beagle's spine and swallow the tag in one bite. In 2024, a study published in Frontiers in Marine Science looked at this case alongside 21 other tag failures from the North Atlantic. For showed nearly identical signs, sharp dives, identical temperature spikes, and everyone occurred inside the Celtic Bisque corridor. That's a seasonal hotspot for mature great whites that follow schools of bluefin tuna into European waters. In 2 of those cases, the tags were briefly detected again, this time inside the stomach of a white shark near the Azores before being spat out. It was the first real proof that white sharks hunt poor beagles in this part of the world. That's a major concern. The poor beagle is already listed as vulnerable globally and endangered in European waters. Back in the 20th century, longline fishing nearly wiped out their populations with numbers crashing by more than 90%. Female poor beagles give birth to just 4 pups a year. So, when a pregnant shark dies, it's not just one loss, it's 5, the adult and the 4 unborn pups she carried. When investigators recovered the tag, they found something else. Tiny tooth fragments wedged into the corrosion grooves. Micro-CT scan showed the serration pattern didn't match a mako or shortfin. It matched Carcharodon carcharias, a great white. DNA swabs taken from the plastic confirmed traces of lamnid mitochondrial DNA. There was no evidence of squid or mammals. Today, the poor beagle case is taught at shark tagging workshops from Woods Hole to Barcelona. Thanks for watching. See you in our next video.